Guys, so here we are gonna discuss a new video, a new question, boundary traversal of binary tree. It's a medium question in GFG. Okay, so boundary traversal means what? For example, boundary means this is not a binary tree actually. Okay, yep, this is fine. So boundary traversal means what are the boundary nodes here? Boundary is this, right? So can I say this thing touches the boundary, 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 this touches the boundary, this touches this boundary, this touches this boundary. Okay, so basically this touches this boundary, this touches this boundary, this boundary, this touches this boundary. So except this node, I can say that all the nodes are touching the boundary. So basically you got the intuition that the nodes which you need to include are all the leftmost nodes, all the right mode rightmost nodes, and all the leaf nodes. Okay, got it. So let's jump into the solution because the intuition is very simple as I already explained. So, yep, actually, how you can get the leaf nodes is that you can just simply check by a recursion call. You can do pre-order, in-order, post-order, whatever order you want to do. Just go and check from right to left or right to right, from left then right, or first right then left, that what are the nodes, which are the nodes which are actually leaf. Just mark those nodes, okay, and add it to your answer. Okay, so I know that first I have to include this, then I have to include this, third number I have to include this, fourth number I have to include this, fifth this, sixth, then seventh. On seventh number I have to include this. So I can say that uh, let me zoom it and then do the same thing. Wait, one, two, three, four, five. Actually, better I don't write the number like this. Okay, I think this is fine now. Let me draw one more node. Okay, yep. So first this, second this, third this. So these three are the nodes which belongs to the leftmost edge, right? Then comes fourth this node, fifth this node, sixth this node, seventh this node, and I can say that 4, 5, 6, 7, and actually 3 as well. These nodes, these are the nodes which are actually leaves. So first I have to do all the leftmost nodes, then I have to uh, include leaves in my answer, and it should be like going from left to right. So what I will do, I will first check for left and then I will check for right. So that is why I had written in my leaf code from left to right. After that, what you are doing, 8, 9 and 10. Okay, or not 10, 8 and 9. So these are the right most. Okay, and it is going from this or from down to up, means 8 is here, 9 is here. So I say that uh, I will be adding like from down to up. It was like up to down, and this is like down to up. Do you want me to change the color so you understand it better? Okay, I will do it. uh, Green color. It is like down to up. The leaves are like from left to right, and it's like going from down to up. Okay, the green lines represent how the traversal is going, so you can think optimal solution and present it to the interview. Okay, so I know that this rightmost thing, how can I do? Rightmost thing I can do is like, I will go from roots left, sorry, right, 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 right. Then after that, when I encounter a null thing or whatever is my condition, I will say, okay, I will go and keep on backtracking. And while backtracking, I will add 8 to my answer. Then while backtracking, I will add 9 to my answer or result. So my 8 get added, and after that 9 gets added. Got it? And in here, in the leftmost edge, you don't need to do anything like backtracking. You can simply, as you go forward, you can keep on adding like 1, 2 and 3. Okay, and then how will you do this leaf? I already told you, call for first call the function for left, and then call the function for right. Now you you would have maybe you would have solved this question, but I want those who were unable to solve this question. You know why you were unable to solve this question? This is because actually I was changing the color of my pen so I was thinking which color to choose now. Yep. So are you able to see this is including two times? Two times by what? Leftmost thing and the leaves, right? Because this thing is a leaf as well, and the last part of leftmost node as well. Similarly, this node is a leaf as well, and the last node of rightmost also. So I don't want to repeat this two times in my answers, of course, and this notes as well. I don't want to repeat this two times. So how can I make sure that this note I don't include two times? So what I did in my solution is I checked for the leftmost node because the recursion because I am finding leaf by recursion, and I don't want to means add many condition in my recursion. So what I did was I will this my leaf code will check this, my leaf code will check this, all the leaves basically, including them, and and my leftmost will not be checking for leaves. My leftmost will not be checking for leaves, but other other than the leaf node, it will check for all the nodes. Similarly, in the rightmost, I will check for all the nodes, but not the leaf node, not the leaf node. Other than the leaf node, I will check for all the nodes. So basically, my condition will be like, uh, if it's the leaf node, fine, okay, no problem. But if it's not the real leaf node, then make sure it's not its next node is also its next node is a leaf node, or means actually I had to say that your nodes next this is my nodes, this is the next is this next is also a leaf node. This was my node. Okay, this node's next is this node, and this node's left and right both are null. So I will make sure that this node is a leaf node. Sorry, this node, after this node, I don't travel. After this node, I don't travel. Nodes next, I don't travel. And why I have written this? L E L E A F. Why I have written this? Because a case can be like when I am given a binary tree like this. Okay, this is my root, colored one. So in this case, so in this case, uh, not this. Yep. Now, so this is my root. This is my root, and here we have null. So in the left, in this left edge, in this left edge, I can't do it like node next because nodes next is already null and nulls next is not possible, right? So for dealing that case, I have written leaf here. Leaf is what? Node next. Okay, so I hope you got my point. If nodes next is not null, then check if nodes next is also not null, and if its nodes next is also not null, which means that your next node, which means the node which you are presently on is not a leaf node, and that is what we want. We should not include the leaf node in our left and rightmost traversal. So left boundary, I am making sure that it's not the node. If my node is itself null, so I will say that okay, my node is itself null. So how can I check it? Right, simply return, nothing to add. If my nodes left, if my nodes left is not null, okay, if my node left is not null means there some node is already present here, and nodes right is also not null. Sorry, is null. This exclamation mark I just slipped. So nodes left is null, nodes right is also null. So in that case I will say the node is my leaf node, and in that case I will say return means nothing to do much here. Just uh, just go back, whatever you have done is fine, whatever nodes you have included already is fine. Otherwise, if it this if it is not the case, if it is not the leaf node, or the node is not itself null, so if it is not the leaf node, then chill bro, then simply add it to your result. Okay, and if you are able to go to nodes left, definitely go to nodes left. And if you are unable to go to nodes left because it may be null, so in that case you can go to nodes right. So basically you got the point, right? It's basically a recursive function. It's basically a recursive function in which I'm prioritizing to go to my left, but sometimes if left is not present because of any reason, like it's null here, so I will mark it as cross. So then I will go to my right node if my right node is possible, and definitely it's possible because of the condition. I told it wrong, sorry. It's not about the condition here, but if I go to nodes right, then if anytime I encounter something leaf, so basically I don't include the leaf, and I will be I will be basically want to go to the left, and if going to left is not possible, in that case only I will go to right, but I will keep on moving a left whenever I can, because it's boundary, right? Similar thing you have to do it in boundary, or this right boundary also. Just the only thing is that you are adding it in your result, uh, while recursion, and it is, and you are adding your node data while backtracking. Okay, so similar to that, it is also a recursive code. And in here also, I want to go to right, I want to go to right, and if going to right is not possible, only in that case I will go to left, but again I will keep on in the next recursive call, I will keep on try to go to right. Okay, so I hope you must have got the idea, but just just because I think that maybe some people don't know, don't understand really quick. So right side will be like, I want to go to right. Okay, going to right is possible. I want to go to right. Going to right to going to right is possible. I will go to right. Right is possible. But now right is not possible. So I will go to left. But again I will start going to right whenever right is possible. But I will not include this node because this node is a leaf. So I will go till here only. Got it? Similarly, in here, if you see, I want to go to left, I want to go to left, but going to left is not now not possible. So what should I do? Better we will make it like this. So I will go to this will be null. So in so when I can't go to left anymore, so I will go to right, and again I will start going to left. So basically I am traveling over the boundary, right? I am just trying to touch the boundary, and leaves are like going from left to right, as I told you that we're going like this. These are the leaves here, this is the left boundary here, this is the right boundary here. Okay, so that is why I've written left here and then right here. And whenever I find whenever I find a leaf node, I say, oh wow, great, you found a leaf node, just add it to your answer. And this is it. First you need to call for this left boundary, then you need to call for the leaves, when you will and then you need to call for the right boundary. And here I have written a condition. What is that condition? This condition is here because my root will be getting added for the two times. Let us read this comment. Check if root has children, otherwise you will add root two times. If I have no children on the left or right, then I will add the root two times if root on if only one node in the child tree present. If only one node in the tree present. So if I am given like this, so what happen is, I am only given one. So one is definitely, wait, let me raise everything first. Okay, so I am given one. Okay, for example, I have given two here. So now one is not a leaf node. One is not a leaf node here. One is not a leaf node in this case also. But one is a leaf node in this case, right? One is leaf node in this case. So what will happen is my leaf node code will also include this, and already I was including this in my left boundary solution. Oh, this result already means already I was including it. So you got my point, right? One is not a leaf now, one is not a leaf in this case, one is not a leaf in this case also, one is not a leaf in this case also, but one is now a leaf in this case. So we, our code wasn't handling this case, so I did an extra condition here that if one is the leaf, so make sure you don't do this condition, means you don't call this function, otherwise you will add 1 2 times. Okay, then right boundary. So this was the code. I hope you enjoyed this video. See you in the next one.